In this video, we're going to talk about a specific type of sequence called an arithmetic sequence. Okay, so we start with the definition. It has this idea of a common difference. So an arithmetic sequence is a sequence that can be defined recursively as, so A1 is some term, I'm going to call it A, and an minus 1 is D for some constant D. Okay, or the way we normally write this is A1 is some term A, and an is an minus 1 plus some difference D. Okay, where D is a constant known as the common difference. Okay, so this is the one we normally think of. But the idea of common difference makes more sense when you think about this form. So if you take the difference of two of the terms, you get this constant D, no matter which two terms it is. Okay, or you can think to get from one term to the next term, you just add some number D. Okay, so for example, these two sequences are both arithmetic sequences. So if you think about this first one, you just have to add 4 to get from one term to the next. Okay, so that means the common difference is 4. And if you notice, so if I take, 7 minus 3, that's 4. Okay, 11 minus 7 is also 4. Okay, so that means that the D here is 4. Okay, I'm going to leave you to think about the other one. So what would the D be in the sequence from that starts 1/2 and then 1/3 and then 1/6, etc. So try and figure out what the D might be there. So using this first one, the recursive definition, we would say that A1 is 3, and then to get to AN, you take AN minus 1. And you simply add, 4 to it. That was the D value. You simply add 4 to it. Okay, again, I'm going to leave the recursive definition for this sequence, which is the same as this sequence, for you to do, but I will fill it in the subsequent video. Okay, so then if you have an arithmetic sequence with common difference D, then you know that A2 is A1 plus D. And then A3 is A2 plus D. Okay, but A2 is actually equal to A1 plus D. So you can replace that, and then you can say that A3 is A1 plus 2 times D. Okay, similarly, A4 is A3 plus D, but A3 is equal to A1 plus 2D. So you can replace, and you see that A4 is going to be A1 plus 3D. Okay, so then we have the 3 here and a 2 here. Okay, a 4 here and a 3 here. So you might notice that the pattern, if I want a n, it's going to be, I could find it, instead of doing recursive, I could take the first term, A1, and add n minus 1 times the common difference. Okay, so 1 less than the term I'm looking for. Okay, so this is an important formula. So I'm just going to put it in a colored box, make it a bit easier to find. Okay, so that's what we're going to use that. So let's do this example here. So what if we want to find the 17th term of the arithmetic sequence 7 to -3? Okay, so now what we'd want to do is so they told us it's an arithmetic sequence. Okay, so this means that because of this, we know there is a common difference. Okay, so i.e. we know that an is an minus 1 plus some d. Okay, and the d could be negative. So here the terms are getting smaller, so we're going to be subtracting. So you could just say, okay, so to get from 7 to 2, I want to subtract 5. To get from 2 to minus 3, I also subtract 5. So that tells me that my d is going to be minus 5. Okay, or you could say just take 2, so this is a2 minus a1. Okay, this is going to be our common difference d. Okay, so that's a2 minus, so any two terms you could do. Subtract them, okay, and we know that a1 is 7, okay, so that means using the formula above, a17 is going to be a1 plus 17 minus 1 times d, which is minus 5. Okay, so that's going to be 7 plus 16 times minus 5, which is going to be negative 73. Okay, so that is equal to a17. Okay, so if you know it's arithmetic, then it's easy to find the common difference. And then you can use this formula to find any term in the sequence. Okay, now to show that a given sequence is arithmetic is a bit harder. So we need to show that the difference between any two consecutive terms. Okay, so that means it doesn't, you can't just do like the first two. Okay, you have to show for any two that the difference is constant. So that means that we're going to want to take two random terms, so let's say an and an minus 1, and subtract them and show that the difference is a constant. Okay, so let's try one of those. So here I have a sequence Tn is equal to 4 minus n. Okay, and so it tells me this is an arithmetic sequence. Oh, but I want to show it's an arithmetic sequence. So I'm going to use the fact Tn is 4 minus n, and Tn minus 1 is 4 minus n minus 1. Okay, so that's actually 4 minus n plus 1, so it's actually 5 minus n. Okay, so Tn minus 1, I want to show this as a constant. Okay, so Tn is 4 minus n, and Tn minus 1 is 5 minus n. Okay, so that's 4 minus n minus 5 minus negative n is actually plus n. Okay, now the negative n and the positive n cancel out. So I know that Tn minus 1 is just negative 1. Okay, so that would be my d value. So this is a constant. Okay, so what I mean by that is there's no n anymore. Okay, it's just a number. Okay, so then since the difference, so these are two random terms. So since the difference between any two consecutive terms is a constant, okay, so namely negative 1, okay, the sequence must be arithmetic. Okay, now I'm going to leave you to show that this sequence Sn here is also an arithmetic sequence. Okay, so you want to use the same idea. Okay, so find Sn and Sn minus 1, subtract them, and see if you get a constant. Okay, so I'll leave you for that one. Okay, so now here, I know that my sequence is arithmetic. Oops. Okay, so I know it's arithmetic, and I know the 9th term is 70, and the 20th term is 92. So what they want is a formula for the nth term and the first term. Okay, so since they told us, so since we know the sequence is arithmetic, that means that we know that an is a1 plus n minus 1 times some d. Okay, and we also know, because it was given, that a9 is 70 and a20 is 92. Okay, so we also know those things. So we can use these each to get equations and then try and solve for a1 and d. Okay, so what they want, the nth term, okay, they want this formula where the a1 and the d are, we know what those are. Okay, so we're going to use these two conditions to find those. Okay, so a9 equals 70 means that 70 is equal to a1 plus 9 minus 1 times d. Okay, so that's 70 equals a1 plus 8d. Okay, now a20 equals 92 means that 92 is a1 plus 20 minus 1 times d. So that's 92 is equal to a1 plus 19 times d. Okay, so now I have two equations with two unknowns. Okay, so a1 and d. So I can solve this. So we've done things like this before. There's multiple ways to solve. So what I can do is take one of the equations. Okay, so I'm going to take this one, and I'm going to solve for a1. Okay, so a1 is going to be 70 minus 8d, not 89, 8d. Right, if I just subtract 8d on both sides, I've solved for a1. Then what I can do is take what I've solved for a1 and plug it into the other equation. That's going to give me an equation with only d's. Okay, so then I can solve for d. Okay, so actually let's keep doing purple. So 92 is 70 minus 8d plus 19d. So that means that 92 is 70 plus 11d, right? So negative 8d plus 19d is going to be positive 11d. And then I'm going to subtract 70 on both sides. So that means 22 is equal to 11d. So then I could divide both sides by 11 to get the d by itself. And I get that d is equal to 2. Okay, now I can plug that into my equation for a1 and figure out what a1 is. So that means that a1 is 70 minus 8 times 2. So that's 70 minus 16. So that's going to be 54. So that's our first term. Okay, so we know that the first term is 51. Okay, and the nth term is going to be, so I want the formula here, so a1, so I don't know why I put 51, sorry, 54. Okay, so a1, so 54 plus n minus 1 times 2. Okay, so I found the first term and the formula for the nth term. Okay, so that's what you can do. If you know it's arithmetic, and then you know two terms, you can solve for a1 and d. Okay, so sometimes we're going to want to add the terms in an arithmetic sequence. Okay, so if an is an arithmetic sequence with common difference d, then the sum of the first n terms, okay, so I'm going to call that Sn. So that's going to be a1 plus A2 plus A3 all the way until AN. Okay, so A1 is just A1, but A2, using the formula, is going to be A1 plus D. Okay, A3 is A1 plus 2D. And you keep going, so AN is A1 plus N minus 1 Ds. Okay, so that means each of these terms has an A1, so there's going to be N A1s. And then I'm going to have D, so if I factor out the D from the other terms, okay, there's a 1 here, a 2 here, a 3 in the next term, okay, up to N minus 1. So this is going to be times 1 plus 2 all the way up until N minus 1. Okay, now we know the formula. This is a sum from 1 to N minus 1. Okay, so this here, so inside this bracket is a sum from k equals 1 to N minus 1 of k. Okay, so we have a formula for that. So it's going to be N minus 1 times N minus 1 plus 1 over 2. So that's going to be N minus 1 times N over 2. Okay, so this is N times A1 plus D times N minus 1 times N over 2. Okay, now the way that they normally write this formula, so I'm going to write Sn again. So if I factor out N over 2, then the first term here, I took out half of the N. So this is actually going to be 2A1. Okay, and then over here, I'm going to have N minus 1 times D. Okay, so that's one way they often use it. Or you can actually rewrite this as well as A1 plus AN. Okay, so these are the formulas for the sum. So the part above is just sort of the proof of why these are the formulas. Okay, and let me just go from here to here. If I write this as A1 plus N minus 1D. So if I break up the two A1s, okay, then I have A1 plus A1, and then I can group them separately. And then this group, this is the formula for AN. Okay, so that's how I go from this formula to that formula. So it just depends what you have, which one you want to use. Okay, both of them, they're the same. So if you want to find the sum, you can use either of them. Okay, so let's do an example here. So I want the sum of the first 81 terms of this arithmetic sequence. Okay, so to go from -3 to negative, so they told me it's an arithmetic sequence, so I know I just want to add or subtract a number. So here I'm adding 0.2, okay, and then I add 0.2 again, okay, so probably my D is 0.2, okay. So we know that A1 is -3, and if you want to actually compute the D, you just take the second term minus the first term. So this is A2 minus A1. So -2.8 plus 3 is 0.2. So that's our D. Okay, so what we're looking for is the sum, so S81. So you can use either formula. I don't have AN term, okay, so I'm just going to use the first one. Okay, so that's 81 over 2 times 2 times A1, so 2 times -3, plus 81 minus 1 times 0.2. Okay, so I just subbed in everything. So this is 81 over 2 times negative 6, and 80 times 0.2 is actually 16. Okay, so this is 81 over 2 times 10, and so you get 405 as your sum. Oops. Okay, so that's a positive 405, so there's going to be more negative terms, or more positive terms than negative terms. Okay, and now I'm going to leave this one for you. So because you want the sum of the first n terms, your formula is not going to be a number like this one was, it's going to be in terms of n. Okay, now this one also does not tell you that the sequence is arithmetic. So you want to be careful. You're going to have to show that it is arithmetic, and then hopefully it is, and then you can use the formula to find the sum. Okay, and then I'm also going to leave this one for you to try as well. So this is a word problem that turns out to also be an arithmetic sequence, and you're looking for a sum. Okay, so try those. So that's the idea behind arithmetic sequences and summing terms that are in arithmetic sequences.